Oh, okay, yes, yes.
I thought you said if their games are canceled.
Aren't.
Yeah. Okay.
I'm just not mentally
Yeah, because you're doing
here. There's no dog's dog.
it. Yeah, maybe just kind of crap.
I'm just like, Blueberry, you can throw up inside. Just throw up inside, please. Just throw up. And she's like, nah, you straight, honey. I'm just like, bro.
Alright,
And
morning
then she
everyone.
goes, it's fine. It's where my feet go.
Alright, so my goal for today is just gonna write some example code in Jack. Just kind of again to help you with some ideas for your projects. And let me say while I'm thinking about the project, actually, while we're on the topic, I just wanted to make sure to point out. So definitely, so we talked about Project 9. So a proposal for that is due tomorrow. You can certainly feel free to send it to me today. Or you should submit it through the form. But again, it doesn't have to be long, just like a paragraph telling me kind of here's what I think I'm going to do. And it has to be ready to demonstrate something by Tuesday, and then it'll be the actual final deadline will be Friday. I just wanted to say, like, this is not intended. This project, most other projects are very difficult, right? This project is not intended to be difficult. I don't care. You don't have to do something super amazing or impressive. I mean, people have done cool, impressive things with this system, like making little games and stuff. You don't have to do that. It can be something pretty simple. The point is just to give you some experience with this language, not that you have to do some impressive project, right? So I just wanted to point out what the specification is. And maybe some of you looked at this, but right, to get credit, you have to turn in a proposal. You have to demo something. You have to have at least 2 Jack files. So you can't just make a main and have some stuff in there. It's got to at least have another class that you call from your main. It has to compile and run successfully, and it has to be at least 100 lines of code. Okay, so like, I mean, yes, if don't submit something that just like has 100 print statements. Okay, I mean, I guess technically that would meet the specification, but you would get a frowny face from me. But I intentionally didn't say anything about like, oh, it has to be like really sophisticated, or it has to use all these features or whatever. So something interesting that you can do. I mean, because honestly, like, just you're going to be annoyed enough just using the system because it's it doesn't have a lot of the things you're used to in other languages and in other kind of computer platforms. So anyway, so that's that. So don't stress about it. Just pick something fun, pick something easy if you want, and go from there. All right. So I'm going to be completely live coding this. I didn't work up an example that I'm going to show you. We're just going to kind of go for it. So I kind of had the idea after last time. So by the way, I did figure out what was wrong last time with why only certain smiley faces were showing up. It's because the smiley face had some blank. Like every time it writes the smiley face to the screen, it's actually setting all the pixels in that whole 16 by 16 square, including the ones that are off. And so if you draw a smiley face, and then you draw another smiley face that's offset a little bit, it's going to completely erase the previous one because it writes over, it's even got blank space around it, so like it'll even overwrite all the pixels. So basically it was actually working correctly. We were just only seeing the very last smiley faces that it drew, and all the other ones had gotten written over on top of it. So my basic idea is I want to make a little. I also thought it'd be useful to show you an example of doing a little kind of graphics programming in case you want to do some kind of little game or graphics-y thing. Because there's some things that it makes easy and some things that we have to think a little harder about, like how to work with this system. So I want to my idea is to get a little basic like sprite of a little character that can like jump. If I can just get something that, you know, it'll jump when you push space. Maybe optionally we can make them run left and right or something, like pressing arrow keys. But so basically like a little sprite that can jump. So like a very basic physics simulation that's just doing like gravity, you know. And optionally, you know, some optional things depending on how much time we have. If we could have like different sprites, that's like a little jumping animation or a little standing animation. Maybe maybe we can get it to run left and right. I don't know, but that's kind of what we're gonna do. So let's start by making a main, and I don't even know. So we need to have a function void main, and this is just gonna say game G. So I'm making a, so this, all this is gonna do is like create a game object and then like tell it to run. And then I'm gonna have a game class that kind of keeps track of, I mean, some stuff. And then I'll have like a little like character class. Then I need to declare my variable, and then we're gonna say let G equal game.new. And then do g.run. And then I guess we'll say do g.dispose. And then don't forget the return. Okay. So the dispose stuff is kind of, I mean, like if we didn't have that, it would still work. It's just nice to clean up after ourselves and deallocate the memory that we allocated, right? So definitely something that, in the example that I'm going to do, if we left out all the dispose stuff, it would still work fine, because I'm really only going to allocate, you know, a single game object and then like a single character object. But if you imagine like, you know, if you made like an asteroids clone where you've got, you know, a whole bunch of each asteroid is an object, and then when you split it into more asteroids, it like makes multiple objects. You definitely want to make sure that you're cleaning up, you're deallocating objects that aren't being used anymore, because otherwise you're very quickly going to run out of memory. So that's kind of the idea of how that's going to work. I wonder if I can, let's see, if I say, okay. So I just, you probably can't see this. I just ran the compiler on it just to see. Now, of course, it won't do anything because I haven't defined, you know, game or any of those other things. I just wanted to see at least if it gave me like a syntax error or if it said, oh, this name is not defined or whatever. Actually, it gave me no errors at all, so there's that. I think basically the compiler does not check whether names are defined. That would happen later, like when it, probably when you actually, I don't know, what? Right, so this generated a main.vm. Yeah, okay, so this makes sense. So here's the VM code that it generated, right? I mean, that's pretty straightforward. It just says, okay, you have things called game and run and dispose. Fine, I'll just turn that into VM code that calls those things. If I now tried to translate this to assembly, even that might still work. It might be like when we actually try to run it. Let's try it. Oh, how do you, okay, wait. Well, anyway, whatever, it doesn't matter. The point is, I mean, if I tried to run it, then it would say it's not fine. But at least we know it didn't have any syntax errors. Like if I take out, you know, a curly brace, and I try to run the compiler again. Right, so now I get a syntax error. You can't see that, but it says Oh, I expected a closing curly brace, so. All right. Let's make a game. Let's see. So what is game gonna need? I guess I'm writing this kind of top down, which I don't know if that's a good idea or not, but that's what I'm doing. So game is going to need a field which is I think it is character. I think that's the syntax. We're also going to be learning the syntax because I don't quite remember the syntax for Jack. And if you notice something that I do and you know that it's wrong, you can point it out, but otherwise we'll figure it out. Let me just go ahead and try compiling this right now and just see what it says. Okay, no errors, so here, I can actually probably make this bigger so y'all can see. Okay, so no syntax errors so far. I don't know if I'll need any other fields. I don't know, maybe we'll start with that. Maybe we could add like a score, like if you're going to keep track of a score, maybe the game can keep track of that. Maybe other things, but let's make a constructor. I think I just say constructor new, like this. Or do I have to say constructor game new? I don't remember. Expected a type followed by a subroutine name. Return type of a constructor must be of the class type. Okay, makes sense. So yes, I have to say game. Now it's going to warn me. Yeah, now it's that error went away. And now it's just saying you're missing a return. So of course, all right. At the end of a constructor, I'm definitely going to have to say return this. So all the constructor has to do is fill out the fields, right? So I guess I just want to say let character equal character dot new. If we add more fields, then of course we can put more stuff in the constructor, but okay, that compiled, no errors. And then we need a run function, right? And we also need a dispose function. So run and dispose are going to be methods because I'm calling them on a specific game object, which is this G here, right? I'm going to say method void run and method void dispose. Let's do dispose first because that's probably going to be pretty easy. All I have to do for dispose right now is I just, let's see, I say do character dot dispose, and then I got to dispose myself, which I do by how does that work? It's like memory dot dealloc. Oh, do memory dot dealloc this. I think. Yeah, that's right. Okay. Okay, and then the run function. I guess this is it's gonna be run. It's gonna have a loop, I guess, and it's gonna say basically. Well, and I guess maybe this is the place where we deal with keyboard input. Probably makes sense, right? It's not the character's responsibility to deal with keyboard input because we might add more stuff other than the character. And so let's say this part is going to be kind of similar to the square game thing, but I'm trying not to look at it to see if I can I guess I need to say var, I need to say what type it is. But I don't think we have bool. I think we have to say int. Oh, no, okay, so let's look for, oh no, we do have Boolean, look at that. Cool. But of course, Boolean is just int. I mean, like, it's nice that we can call it a Boolean, but fundamentally, it's really just gonna be stored as an int, just like everything else. This is the kind of thing where, if we were going to add some static type checking to the language, right, it could use that information and say, oh, you know, you wrote exit plus 5, but that doesn't make sense because exit is a Boolean and 5 is an int and you can't add Booleans. I don't think right now the language actually cares. I could say exit plus 5 and it's like, yeah, no problem. We'll just take that value and we'll add 5 to it. And like, yeah, I hear, actually, let me see. Exit. Can I write this? And then let exit equal exit plus 5.
I really hope it compiles.
What was that?
I really hope it compiles.
You really hope it compiles?
Oh.
A numeric value is illegal here. No, it does have some basic type checking. That's line 13. Yeah, this line. Okay, cool. Look at that. You don't have to do this when you write the compiler. You do not have to implement this, but yeah, okay. Huh. And if I could, I bet also this is not allowed. Oh, dispose. It's complaining about dispose also. So you always forget to return. Okay, no, it's okay with this. This is fine. You know, because, so it's got like some very limited type checking. It's not even really type checking. It's like, it's just like a few cases where it's like, yeah,
It's a little sus, bro.
can't put, I don't know why. Maybe we're not gonna do that.
Can we
Exit equals false. You know, I'm gonna call it done. Okay, that's good. So I'm gonna say while not done.
Oh, I don't like that.
Wait, is not
That's
the
a little-
till?
Yeah. You don't remember, we saw it the other day. What would you prefer it to be?
Exclamation point.
Exclamation point, okay. So, when you write your compiler, you're welcome to put in, you know, you have to do the tilde because it has to be able to compile the existing test cases, but you can also put an exclamation point and then you can use that. Actually, adding that would be very easy because you just like add one more if that's like, oh, if it's an exclamation point, then I'll treat that as not also. I don't know why they made this choice. I have no idea. Because I don't think they use exclamation point for anything else, so it wouldn't really be.
Well, you need
I don't know why.
factorial.
I don't know. Who knows? Let's see. So what do I want to do? I want to say like.
Just seems like an approximately equal to.
Okay, I'm going to cheat a little bit because this is not like the most interesting part. I'm going to look at that square game example.
I love how this compiler tells you every error you have, and it's not just like, well, this is the first error I found.
Yeah,
Ah.
that's nice, and that's kind of difficult to do. So, yeah, it's impressive.
Why can't every compiler do that? Crazy debug.
I want to say like update, and then I don't know what we're gonna do here. Something. Yeah, this should work. And I think I mentioned this the other day, but like, if you're really implementing a game, like not on the hack machine, but just in real life, if you're making a game, this is a terrible way to organize the code for your main loop, where you have like two different loops waiting for keys to be pressed or not pressed, and then like you update stuff in the middle. But most frameworks in which you'd be writing a game give you something more like a queue of events, and you're like, see if there's a new event that has happened, and if so, I'm gonna process it. You're not like literally, seeing whether a key is pressed or not. There's like some lower level thing that's doing that. But this is the limitations of the platform that we're on. So this is a reasonable way to do it for this. The other thing is that it's going to be just updating like as fast as it can. And so, how fast the animation runs is just dependent on like how fast the simulation is running on your computer, plus how much computation the program is doing in between each step, right? So that kind of sucks too, because it's like the game may actually like speed up or slow down depending on how much computation is happening. And of course, we're all familiar with, when too much starts happening in a game, it starts to lag and stuff like that. But like this is going to be that on steroids. It's like not just lag; it's just like the speed of the game is directly proportional to how much stuff is happening. Of course, that's not how you do a real game, but we're not gonna worry about that. There is the operating system does provide like a wait or sleep command. I forget what it's called. That'll like pause for a certain amount of time. But actually, secretly, like it doesn't. This computer doesn't have a clock. I mean, it has a clock in the sense of like the clock that goes 1 and 0 that drives all the components, but not a clock in the sense of keeping track of what time it is. So honestly, I was like, oh, that's cool. I wonder how it works. And then when I got around to implementing it with the operating system, it's like, well, just just put a loop that like spins for a certain amount of like 100 times, and then time it and see how long it takes, and adjust it until it seems about right on your machine. I was like, that's okay. That was disappointing, but that's really like the only way it can do that. So, all right. So for now, let's say we'll do Q is quit. So we'll make done true. And right now, I just want to handle the space key. So if key equals now, how do you know what number corresponds to what key? There might be a table in your book. You can also, curious, like an appendix. The hack character set on page 315, appendix 5. There it is. And yeah, you definitely want to look at this because like, basically up from 32 to 126, it's just the same as ASCII. So if you just looked up, any table of ASCII values, you would find it. But after that, it's got codes for like backspace, left arrow, up arrow, right arrow, escape, F1, F2, F3, all those things. And those have nothing to do with standard codes for those keys. That's just like they just made up a list of things. So if you want, especially if you want special keys like that, you just have to look at this table in your book, and it'll tell you what numbers correspond to those things. So space is 32. That's the same as an ASCII. And if space is 32, I want to say like do character dot jump. And we'll figure out what jump does later, but get rid of this stuff. Okay, and then I'm going to make a method void update, which I called here. For now, all the update is going to do is just going to call do character.update and return. Right? But if my game had multiple objects in it other than the character, this update could call the update method for each of those things, right? Maybe even if I had like an array of things, I could have a little loop that went through the array and called update on each thing in the array. Like maybe if I wanted to have, all enemies or something, and there could be like a bunch of them, you could put them in an array. And that's why I made a separate update method, because of course, like I could have just said do character.update right here. But just thinking ahead to like if I want to add more stuff to my game, I don't want to have to write out all the things that need to be updated, you know, both here and here. So I just made it into a method. Any questions so far? Kind of haven't done the most interesting part yet. Let's make sure that it's, oh. Key is not defined as a field, parameter, or local or static variable. Line 15. Oh, key. Oh, did I have to do, oh, I have to say var key, var int key. Let key equal 0. Actually, so here's a trivia question. If I don't initialize key, what will I get?
Probably.
Probably an error.
Well, we don't know, we have no idea of knowing like what key is or whatever might have been in the stack, or no, whatever might have been, yeah, whatever might have been in the stack before.
Okay, so, yeah, so
So
one.
it's just gonna be something.
So it could just be like, you know, it allocates some memory space for it, and just whatever value happens to be there, that's what value it'll start out with. That is one possibility. Yeah, Simon?
You just get 0,
So you think we'll just get 0? Why?
because whenever the virtual machine like allocates some like local memory space, it just fills it all in zeros.
Yeah, yeah, it actually does. So if we didn't do that, right, so the virtual machine wouldn't have to do that. We could just imagine just like incrementing the stack pointer, you know, adding 4 to the stack pointer, however much to make space for your local variables. And then like what Zach said would happen, where just like whatever values happen to be there in that part of memory would just be like what values your variables have. But it's kind of convenient that, in fact, yes, the virtual machine guarantees that your local variables will all be 0 by like pushing zeros on the stack. So it turns out that actually I don't have to initialize it. So it will be 0. It might still be good programming practice to explicitly initialize it to 0, just because then you can understand the code better. But that would waste CPU cycles. We don't want that. Yeah, exactly.
Does that mean that Boolean will be true by default?
Boolean will be, no, 0 is false.
I thought 0 was true.
No, 0 is false for Booleans, and then true is like all ones.
Okay.
-1.
Okay.
Yeah. Yeah, so I guess I don't have to initialize done either. Like that'll be false by default. That would be probably even more confusing and magical if I left that out.
We gotta pad line count.
Exactly. But, okay, but this is an interesting point. You know, a straightforward, naive compiler would just, when I say let done equals false, it'll just translate that directly into, you know, something that does the assignment. But you can imagine starting to do more kind of optimizations, and real compilers do tons of optimizations like this, where, for example, it could say, aha, I noticed that you're just initializing it to false, and I know that that's the default value, so I'm just going to omit this. I'm not going to actually generate code for it because you can't observe the difference, and it'll be faster if you don't explicitly like write a 0 into a place where there's already going to be a 0. I don't think this compiler does that, but good. All right, let's try compiling again. Okay, no errors. Woo-hoo. So now we're gonna make our character. So let's see. So let's make a little sprite first. How about that? So if I
Oh.
I'll use my amazing art skills It's annoying that you can't like. Version of the weird shaped head. It's reasonable.
Give it a sword.
What was that?
He said give it a sword.
A sword, okay, alright. I don't condone violence, but let's make it a little longer. Here we go.
It's a pencil.
It's a pencil, yeah, definitely a pencil. Okay, and then we want to make method. And there was something about this that wasn't quite right. I don't remember what it was, but remember
did
when
this
we had
one.
to edit it somehow. What?
You didn't do var mem address.
Oh yeah, it has to say var mem address. Okay, we'll put that in. So character dot.
I guess if we only have this blank, we don't have to worry about the white space.
So we're definitely gonna. Well, what? Oh, it's like a tab character. Oh, this all needs to be here too. Okay. We'll come back to this because we're probably going to need to edit this bit. But for now, I just want to get it. I'm just going to do the minimum amount of work possible to get it running and drawing something on the screen, and then we can go from there. So I need to make a constructor character new, and doesn't actually need to do anything right now because we don't have any fields. And we're going to make a method void update, which also doesn't need to do anything right now because we don't have any fields. We'll add some in a little bit. And then I need to add a method void dispose, which just follows
Do.
yes, do. I always forget to do, thank you. Forget do, I forget return. Alright.
I think you also need to make a jump function.
Oh, do I? Oh yeah, I need to make a jump. What is it called? Output print, something like this. I don't know if it's actually what it's called.
It might be print string.
Print string. Maybe. This is appendix 6. Screen. Keyboard. Oh, output. Output print string. Yes. Okay. Do.
Oh.
Output print string. Return. Okay.
Oh, yeah.
Huh, yes, all right.
I miss Python already.
No. So what I should be able to do is to call Jack compiler on the directory itself instead of on individual. I can call it on individual .jack files, but I think I should be able to call it on the directory itself. There we go. Okay, so it, yep, compile all of them. So now what I should be able to do is I should be able to run the VM emulator. And you know, again, in theory, I could further compile these VM files into assembly, and then I could run the CPU emulator. It would also work, it would just be slower, right? So if we directly run the virtual machine emulator, it's not doing all the assembly stuff, it's just directly emulating the virtual machine instructions. So it's gonna be way faster. So where are we? No, not slow.
Kind of slow.
Okay, program halted. Allocated memory size must be positive. Well, I wonder if, that makes me wonder if it's upset about the fact that the character has no fields. So it tried to allocate an object of size 0 because it doesn't actually contain any fields. So let's just add a, I mean, we're gonna need a field int x. Can you say that? I don't remember. Making that up. Okay, it's running, nothing's happening. So main, and called game new.
Should we actually call draw anywhere?
Maybe we didn't actually call draw anywhere. Yeah, that would probably do it.
Jump doesn't call draw.
No, I mean,
Update
jump
doesn't.
shouldn't call draw. Yeah, I need to add that to my game loop.
You'll need to add it to update.
Yeah, update should update things and then it should draw. There it is.
Now I know how to easily get those 100 lines.
Yeah, right. Not gonna take too long this time. Oops. Still don't see anything.
Did you recompile it?
Did I recompile it? No. Why would I do that?
Draw also needs an argument position.
Oh, yeah.
Character.draw.
That's
Needs
right.
argument
Well,
position.
yeah.
Or we could.
For now, I'm gonna, that's not gonna be correct, but I'm just gonna put in a 0 again, just to get something on the screen. And then we can, hey!
So tiny.
There it is tiny, yes. I mean, I don't know how to make it bigger. So, I mean, to make it bigger, right, you could start doing more sophisticated things, like you actually have like 4 16 by 16 sprites that you write all of them, you know, at a certain positions relative to each other. So you can have something that's like 32 by 32. Or, I mean, I guess you could, yeah. I mean, this tool lets you make 16 by 16 sprites. Of course, you could just like directly make your own that are bigger using the same kind of approach. There's nothing inherent in the machine itself that's limiting us to using like 16 by 16 sprites. So, and I also can't zoom in, but that's okay. I think if we can get it to jump, then you'll probably be able to see it jumping. Okay. So, what should we do next? I think, here's what I think we should do next. I think we should, our character is going to keep track of an X and Y position. And I think we need to figure out, so I'm going to call this, I'm actually going to change the name of this to, because like this location that really, like, figuring out that location should not be the job of someone calling this draw function in the character. Like, it should be the character's job to say, oh, where is my X and Y position? What, I can calculate what screen position what screen location that corresponds to, and then, so I'm gonna call this like, you know, draw raw. Say that 10 times fast. And then we're gonna make a method draw that's gonna compute the location and then call, so at here, when I call draw, I don't want this 0 anymore. Okay, so how do we figure out the position? So the screen, and this is, we have to look this up. So the screen is 16K pixels, but I forget the exact dimensions of it. So where is that going to be? Does anyone happen to know?
I'm using one of the colors ones. Project 3.
How wide is it?
Yeah, that's what I want to know. Right?
Oh, it was in one of the previous projects.
I
Yeah,
think it's Project 3.
for sure. Oh, here it is. 256 rows of 512 pixels per row.
There we go.
Okay, so screen, write that down if you go. Screen is 256 rows of 512 pixels each. Okay, so 512 pixels is 512 divided by 16, which is, so 512 is 2 to the 9th. So 9 minus 2 to 16 is 2 to the 4th, so 9 minus 4 is 5, so that's 32 memory locations. Okay, so each line of pixels on the screen is 32, 32 memory addresses, right? Because each one is 16 bits and it represents 16 pixels of the screen. So I want to, what do I want to do? My X position is, this way, my Y position is this way. So first of all, if we want to think, why not? We'll have Y, conceptually the X, Y position, Y will go from 0 at the bottom to like 255 at the top. So to convert it to an actual screen coordinates, we've got to flip it. So we'll do like 255 minus Y. That'll give us like counting from the top.
Yes.
And then I want to do, whatever my Y is, that's how many rows down I am. I multiply that by 32 to get, the number of memory locations I have to skip to get to that row, and then I add X. Well, I add X divided by 16, right? Because X is the actual pixel coordinates. And then I have to, no, wait. Yeah. Yeah, okay, so actually this is an interesting limitation of this. Because, that's interesting, I hadn't thought about that. Because we're trying to, this function is designed to draw this 16 by 16 sprite to the screen as quickly as possible. It's doing it by just slamming a whole 16-bit value into each memory location one at a time. But that means that the sprite has to be aligned to 16 pixels left and right. So because I can't have it be moved 8 pixels over, because then part of the value would be in this memory location and part of it would be in this memory location. And that's not what this does. This just takes the whole 16 bits and puts it in one memory location. So it has to be it can only be in columns, 16 bits each. It can be here or here or here, but it can't be here. You could design something that will draw anywhere, but it's going to be slower because you now have to split up your values into multiple memory locations and figure out. And that would be a nice kind of exercise to figure out how to do it. You need to do some kind of bit operations to figure out how to split up your value, and then shift bits or something and write it into the different parts. But interestingly, it can actually be anywhere we want vertically. It doesn't have to be aligned to 16 pixels vertically, because each line is just a different position memory. So did someone have their hand up?
Yeah.
Yeah.
I was gonna say whatever if you get one of like the HTML bitmap generators, they have, at least the one that I found, has a shifting method
Okay.
in it for shifting side to side, so
Oh,
it might be
cool.
possible just to like look at the HTML code.
Okay,
and
not this
pull-
one though, or?
Pull that out. I think
A different one?
I think we're using different ones.
Yeah, okay.
I just found one on GitHub.
Okay, cool. Yeah, so certainly if you want to, go this route and you want to have do it in a more sophisticated way, you can certainly look at that. But, all right, so we're just gonna say, so for simplicity, here's what I'm gonna do. We're gonna still have our x and y coordinates be in terms of pixels. But for the x coordinate, we're just gonna divide it by 16. So it's just gonna like round it to the closest, like 16 pixel, multiple of 16. So like if I move it, if I say move by 2 in the x direction, it's not gonna actually move because it's still, but if I move it 16, now it'll suddenly jump over. Again, that might not look the best, but it'll work fine.
It teleports.
We can still have it jump. It'll look nice when it jumps because we can go anywhere in the y direction. So what I want to do is I want to say var int location, and I'm going to say let location equal, well, I'm going to do, it's my y coordinate times 32, right? That's because I have 32 memory locations per row of the screen, plus x divided by 16. I have to remember to put parentheses. And then we're going to say do draw raw location. We'll test this. We'll probably also want something to like erase it so that we can move it, and the previous ones won't stick around. But
It might erase itself.
what was that?
I said it might erase itself.
Well, it'll erase itself if you move it only slightly. But if it moves in the x direction, it's not going to erase itself because they'll be completely disjoint, right?
We could easily store the last location and just
Yeah, we can
have it
basically.
write all zeros to that.
Yeah, basically what we'll do is, yeah, we could either. Yeah, I don't know. We'll think about it in a second. Let's test this. So now if I run this, okay, it's in a different position. That does that look like 50-50? Yeah, actually, I think that does because if this is 256, that should be about a fifth of the way down the screen, which looks about right, and like a tenth of the way across. And if I, I don't know, let's in the game. Let's say, well, here. We'll just do this. For now, my update will say, let x equal x plus 1, let y equal y plus 1. Because the game is calling this update in a loop, right? So every time we update, for now I'll just have it moving across the screen, just to test it out. So let's stop this and reload. Whoa! Okay, well that was very fast, but it worked. Did it? I guess.
We didn't tell it to stop at the limits.
Yeah, of course, I didn't tell it to stop, right? But I'm like, wait, why was it only going by, like, because I was going by 1 pixel at a time, right? So why are we seeing only that? Well, that's because, like, basically each 16 steps, it was actually, it's constrained to this x coordinate, and it was the y was moving down, but each one overwrote the previous one. Like drew over the previous one, and then when it finally jumped over, then it left that one behind. We could probably make it, I mean, that's probably going to be way too fast, right? So we should probably put in a, what is this called? Sys.wait. give it a number which is in milliseconds. You know, so if I wanted to do like 30 frames per second, then that would be about well, we'll just say 30 milliseconds. 33. Whether that is accurate on my computer, I don't know, but yeah, so that's exactly what's happening, right? It keeps overwriting itself and jumping over it, and then it crashes because it tries to write outside the screen. All right, well, let's see. What is next? You make it jump.
Dispose.
What was that?
Do we need to use dispose to get rid of some of the things?
We need to use dispose to get rid of what?
Some of our drawings.
So dispose doesn't get rid of the drawings. Dispose deallocates the memory that the object is using. And we don't want the object to go away. Right? I mean, you could imagine dispose like erasing something from the screen also when an object gets deleted. But, let's make an erase function first of all, so it can like no. I mean, okay, I guess running into the fact that this is maybe not organized in the best way, but for now, we'll just do it this way. I don't like this because it shouldn't really be the job of the update function to like draw stuff on the screen. It's just like updating the state of the variables, but I don't know a better way to do this. We're constrained by the fact that in order to make things run reasonably fast, I think we want to do the thing where you we have to like, you know, just erase a part of the screen and redraw something, not redraw the entire screen every step, right? In a real game, the way this is typically handled with something called double buffering, where basically you've got, at any given time you have two arrays of pixels to represent the screen, and you know, it's currently displaying this one, and you just like draw the next frame just completely from scratch in the next, you know, array, and then when you're ready, you basically just swap them. You're just like, you point something at the other one and say, okay, no, now draw this one. And then the other old one becomes now, I'm gonna like, just draw over it and just draw everything from scratch. So in that, when you do it that way, you don't have to worry about erasing things ever. You just draw everything from scratch every time. But I think with this machine, that's gonna be too slow. I mean, I don't know, it seems pretty fast so far, right? But I think if we were actually drawing all the pixels on the screen every step, that would slow it down quite a bit. So, Zach?
Could you also just like compute the difference between the two images, or is it just easier to only?
Yeah, I mean, that would be cool and clever, right? If you actually figure out like the difference between them, and like you only draw which pixels actually need to be erased. But actually, drawing individual pixels is kind of slow because you have to do a bunch of math to figure out. You read in like the current contents of the memory there, and you do like an XOR or something, and you know, figure out the new value, write it back. Just writing a bunch of zeros in those memory locations is going to be just as fast probably as trying to individually overwrite the pixels, right? Again, that's kind of an artifact of the fact that this machine is using you know, one memory location to represent 16 pixels, right? Which is pretty atypical. If you have like a color display, right, then each pixel needs, you know, probably at least 24 bits to represent the color. And so you're not going to have like multiple pixels in one memory location. So writing a single pixel is going to be very fast because you just write a single value to one or a few locations in memory. Whereas here, writing a single pixel involves like doing a bunch of math to figure out, so you don't mess up the other pixels that are in the same location. This definitely gives me even more respect for like developers of early Nintendo games, because this is exactly the kind of stuff they had to be thinking about all the time. When they're like, okay, like we've only got this much memory, and we've got to, we have a hard limit of, it has to run at this many FPS, and so like that means we have this many CPU cycles that we can use to calculate the next frame, and they had to pull lots of tricks to get it to fit. Okay, so, but this is what we'll do now. So we'll say erase is going to say do the same calculation here. And then, again, just to get this to go fast, I'm going to make a but all these are going to be 0. It's just going to write zeros everywhere in that 16 by 16 grid. So let's try that. If I reload it, run. Yay! So that's pretty good. So, and the important thing is that, right, we erase, then we update and we redraw it, and then we do the weighting. So most of the time it's going to be just waiting there with it drawn on the screen. So we don't notice too much flicker going on, because there is like, and again, because you're not doing the double buffering thing where like you instantaneously switch from one frame to the next. There is actually like a small instant of time every frame where the screen is blank, because it erased it and hasn't redrawn it yet. And that's gonna, that'll cause it to look like it's flickering a little bit, but that wasn't too bad. Okay. All right, I just want to get it to jump. Come on, we can do this. So I need to make some velocity fields, and velocity x is 0, y is 0, and when we update, now we're going to do a very basic like physics thing. So we're going to say, so the y velocity is going to decrease by 1 every step. That's like gravity, right? So your y velocity is getting bigger negatively, and then we're going to say x is x plus the x velocity, y is y plus y velocity. Of course, I guess really I'm implementing Flappy Bird, because gravity is always on. Like, you could imagine making some kind of if where it's like, oh, if it's on the ground, then we're going to reset the gravity to 0, and then we won't add to the y velocity every time step. So you would subtract 1 or not, depending on whether you're in the air currently. You can keep track of that. Probably we're not going to have time to do that, but at least. And what jump is going to do, oh, I didn't even try this. It was supposed to like print out jump when I hit space or something. Wait, let's try this. So if I hit, yeah, it prints jump. Okay, cool. That part is working. But instead of printing jump, I'm going to say we're going to make the y velocity be equal to 20. I don't know. We can try it and see how well that looks. Let's also instead of 50, we're going to say the x is 100 and the y is oh, I was supposed to do like y minus, like, I forgot to do that part. This is supposed to be 255 minus y, so that we flip it from top to bottom, right? Okay. So y will start at 10, so that's like near the bottom of the screen. And, actually, I'm gonna have to jump pretty quick so it doesn't fall off the bottom of the screen, so maybe I should. I'll start it more in the middle. It works. Great. Why? Oh, wait a minute.
So you can go up as high as you want. You just can't go down.
Yeah, so you know what was happening? When it went up off the top of the screen, why wasn't that an error?
Because it's RAM.
Yeah, because it's just writing into RAM. Like it was like, oh, the location is negative now, so we're just gonna like subtract something from the screen address and start writing there. So just like random areas of RAM. So actually, I mean, this is a great example of like a buffer overflow bug. If you make him jump high enough, he can start overwriting like, you know, actual data that we need for our program, and it'll like totally crash or something. Because right, like that area of RAM is not really being used. The part that's right next to the screen, because that's like, it's mostly, you know, up. Anyway, wait, why? Oh, X 500. Okay, the screen's only 512, so we'll make it 200. Let's make this. Make this a little smaller. Totally works. Go. Yep, see, totally. Or actually, I don't know, maybe.
You don't have to press that nearly as many times as I thought you would.
No, I'm looking at the RAM. I don't see. I don't know. I'm not seeing. I thought I would see like a bunch of random values written throughout RAM, but I don't see that.
Maybe because it's also erasing.
Oh, that's true. It was erasing itself. Yeah, you're right. I think it just like we jumped so high that it went past 0, and so it got to negative. So it said a built-in function tried to access memory outside the heap or screen range. So I think, yeah, it just, I don't know, we could add like an if or something to make sure it stays on the screen. Maybe we'll just say like, if x is greater than, oh, it's really the y that's the important one, right? So if y is less than 0, then y. If y is greater than 255. Let's try that. Oh, because if my y coordinate gets all the way to, if my y coordinate is 0, that's where like the top left corner of the sprite is gonna be. It's gonna try to write past that. Anyway, whatever. Yeah, we could. So we'll just say like 200. I don't know what the right thing is, but then we'll. Oh, what happened?
Because we said it equal to 255.
Oh, thanks. Yeah. I'll do that. No.
Never mind.
All right, whatever. I don't know. Doesn't matter. There you have it. You are. So you're welcome to kind of use some ideas if you want to make something kind of similar. Obviously, there's lots of things. Don't feel like you have to. Actually, you know, the one thing I didn't show, which I'm not going to do it right now, but you know, there is this screen module that comes with functions to like draw lines and circles and squares and stuff like that. So you don't, if you're doing anything graphical, you don't have to do it like by writing sprites to the screen. You could do it just by drawing shapes and stuff. So actually, the square game thing had an example of that where it's drawing a square to the screen, and that's using something provided. But you don't have to do something graphical either, right? You could just do something that's text-based where it's like, you know, doing text kind of stuff, or whatever you want. So, there, Gary, do you have a question? No? Any other questions? All right. See y'all on Tuesday. Have a good weekend.